Greetings from Baltimore, Maryland. My name is John McGrady, and I'm an associate scientist in the Department of Biostatistics at the Johns Hopkins University Bloomberg School of Public Health. And I'm thrilled to be here today to tell you about my first Coursera offering, Statistical Reasoning for Public Health, Estimation, Inference, and Interpretation. So what do you think about when you think about statistics in general? Well, you probably do think about math at least a little bit, and mathematics is important to everything we do in the statistical process. It helps us do the estimations, quantify uncertainty, etc. So estimation is a very important part of statistics and certainly is incredibly important in what we do in public health and medicine as well. Estimation is the process by which we take raw data and create quantities that summarize it in groups or between groups to help us understand scientific processes. So for example, we might want to measure response to a treatment on a group of individuals, or quantify the difference in response to people who get a treatment versus those who don't. Or we want to quantify the relative burden of disease for two different populations, or understand how much survival is improved by patients who get a certain treatment versus those who don't. So in this course, we will focus on some of the commonly used tools for estimation. We'll talk about why they are the commonly used tools and the pros of using these tools versus others, and then the cons of using these tools versus others, and what we can and can't learn from them. Equally important as estimation is understanding that generally we will be studying subsamples from the larger populations or processes that we wish to learn about, and hence the estimates we get will only be estimates of some quantities that we can't actually observe. And depending on the type of study we do, the size of the study, etc., the estimates will have varying degrees of uncertainty associated with them. So quantifying the uncertainty and calculating our estimates of associations, adding in the uncertainty to make a stronger statement about the unknown association at the population level will be an important part of what we do as well. And this is where the role of inference comes in. Actually quantifying the uncertainty in our estimates and using that to make a blanket informed statement about the unknown association or measures that we can't observe directly. And this is where we'll get into the realm of things like p-values and confidence intervals. But all of this estimation inference is only useful so far as we can interpret in a scientific context. So we'll spend a lot of time in this course looking at the results from studies and the results from the estimation and inference part and asking, what does this mean in this context of what the study was set out to measure? You know, the result is statistically significant, but does it mean anything scientifically? Or maybe the result wasn't statistically significant. Does that mean we discard it, say there's no association, or are there other things to consider? We're going to ask questions like, how can we get a large association and a small association at the same time using the same data set? And we'll certainly ask questions like, how can you interpret these results in the context of the study design used to gather the data? We will aid and abet all the work we're doing with real examples from the literature, focusing on both classic studies from medicine and public health and contemporary examples. The core pieces of this course will include lectures given by me, which are narrated slides with video interjections, online discussions that you'll do in your class forums, exercises that you can work on together and discuss the results of, intended to solidify your understanding of the concepts and ideas that we discussed in the course, and then some quizzes to test your knowledge and see how well you've assimilated the material. I've taught this class, or a version of this class, online for 13 years and constantly updated based on changes in the field and feedback from students, but I've never had the opportunity to take it to the whole world via the internet. So this is a really exciting opportunity for me, and I hope to imbue you with the excitement, joy, and utility of statistics and give you some context for its utility in public health. Suppose you get the bug and get really excited about what you could do with statistics and biostatistics and want to take it further. Well, certainly there's a wealth of other opportunities on Coursera taught by many great instructors from many great universities. Here at Hopkins, we have a couple more offerings that would add on to your experience from this course. For example, if you wanted to actually take on the computing component and learn how to compute with data some of the measures and intervals we discuss in the course, there's a course taught by Dr. Roger Pang on using the freeware computing package R. If you want to learn the mathematical underpinnings of some of the methods we come up with and their derivations, then Dr. Brian Caffo teaches a course on mathematical biostatistics called the Mathematical Biostatistics Boot Camp. And finally, if you want to get your hands dirty and get on with some data and do some analyses on your own using the tools from the package R and some of Dr. Caffo's information, Dr. Jeff Leake teaches a course called Introduction to Data Analysis. In any case, I look forward to this journey with you and connecting with you online and onward and upward with statistics.